Okay, so in this video, we're going to introduce another function that we're going to see a lot in this class, which is the unit step function. Okay, you might have seen this before, unit step function. So what does it look like? Well, it just is 0, and then at t equals 0, it jumps up to 1. That's really it. We denote it by u of t. Okay, and so let me just write what it is mathematically. So it's either 1 or 0, and it's going to be 1 whenever t is positive, and 0 whenever t is negative. Okay. And just like for the unit rectangle function, we don't really care what happens right at t equals 0, mostly because we're often integrating this function. If you remember from calculus, if I change the value of a function at one point and integrate it, I get the same integral. Okay, so it turns out whatever value this function has at t equals 0 isn't going to affect any of the answers we get. And even some people take it to be different values. Some people say it's 0 there, right? Some people say it's 1 there. Some people even say it's in the middle, a half there. So we're just not going to worry about it, and it's not going to affect anything we do in this class. Okay, so that's the unit step function. And let me just make a note about this function, kind of relating it to another function we've seen, that the unit step function is actually this integral of the delta function. Okay, so I'll call it delta of tau d tau because I'm using t here. So let's just make sure we understand why. So let's look at a couple cases. So what happens when t is less than 0? We'll consider this case first. Well, then I have my delta function, but I'm integrating it from negative infinity up to some value t that's less than 0. Okay, sorry, this is my delta of tau. Okay, so what's going to be my integral of the delta function from negative infinity up to some value t that's less than 0? You can see here that the delta function is outside the integration limits. Right, and so we're really not integrating anything. We're just integrating 0. So when t is less than 0, the integral of this delta function is just 0. Okay. What about case 2? What happens when t is greater than 0? All right, so we've just shown when t is less than 0, we get 0. That's looking good for this function being the unit step. What about when t is greater than 0? Do we get 1? And I think you can probably see that, yes, we do. I'll just draw it out anyway. So if this is my delta of tau, okay, and now I'm going to still be integrating from negative infinity up to t. It's just now t is greater than 0. Okay, those are my bounds for my integral. And now we can see that the delta function is inside the integration limits. And so, of course, that means when t is greater than 0, what do I get for this integral? Well, now I am actually integrating across that delta function, and so I should get its area, which we saw in the previous video, as 1. Okay, so all I'm saying here is that this integral, what have we just shown with those two cases? We said, all right, when t is greater than 0, I get 1. When t is less than 0, I get 0 for that integral. And sure enough, that is exactly our unit step function. Right? It's exactly the definition of our unit step function. Okay, so this is what we wanted to show, that that integral was the unit step function. Okay, and now what we can do is we can just take derivatives. We're taking derivatives of both sides gives another alternate form of this idea, which is that the derivative of the unit step function is the delta function. Okay. So you can kind of see, if I take my unit step function and I differentiate it, of course, the derivative should be 0 everywhere. The only question is what happens at 0. And at 0, we kind of get this instantaneous jump that jumps up an amount of 1, okay? And that's kind of what the delta function is doing. It's jumping up. It's kind of modeling that jump instantaneously right at 0, but somehow the area is just 1. And that's what we saw with the delta function properties. Okay, so it kind of makes sense, but this is, proving it more in depth. And so we get that the derivative of the unit step function is the delta function. Okay, so we're going to be using the unit step function throughout the class, and this is just, a relationship between the unit step function and the delta function. Okay, so that's it for this video. I'll see you in the next one.